So far in coordinate geometry, we've looked at midpoints, gradients of intervals and lines, equations of lines, the distances between 2 points, and through all of this, we've used numbers to define the coordinate points on the Cartesian plane. But today, we're doing something which is using those exact same skills, but it's harder because we're using pronumerals. So we don't know the exact location of some of the points that we're working with, and we need to be able to do things like find lengths and midpoints and gradients just using the formulas that we've learned. So you should already know technically how to do this, but you just might not have done it before. My tip is to just go slowly and take care, graph what you can, and that way you can sort of get a feel for where things might be, even if your graph or your drawing might end up being not to scale. That's totally fine. So here, in this example, we've got points A, B, and C. Now C is 0, 0, so I'm sure of that. I can put this on the origin. Point A, 2A is 0. Now I don't know how big A is. A, B, and C are all bigger than 0, so they're all positive numbers. So that tells me that I'm working in the first quadrant here. However big A is, I've got to do 2 of those, but the Y value is 0, so that tells me it's somewhere here on the x-axis. So I've just gone along however far and labelled this point A. And then the point B has the coordinates 2b, 2c, and I don't know what b and c are. So I've put it up here. It looks roughly between these two, but there's no way of knowing. It could be out here compared to the other two. I'm not really sure. So I've just labelled it up there in space somewhere. Now in this question, the first thing I need to do is find the coordinates of P, and P is the midpoint of AB. So it would be helpful if I draw a line between AB and think about that midpoint. I could even label it P before I've found the coordinates of it, so that I'm thinking about what I need to know here. I also need to find Q, which is going to be the midpoint of BC. So if I draw BC in and put the midpoint in and label it Q, gives me an idea where I'm going. All right, so let's find P first. Now we know our midpoint formula. To find the midpoint, let's just remind ourselves. We basically just average the x values. And to average things, you add them up and divide by how many there are. So you add them together and divide by 2. And then you average the y values. So all we need to do is say P is going to be, well, what's it halfway between? Here and here. So my 2a values are 2b and 2a. You can put those in any order. Let's put the a's first. 2a plus 2b, and I need to divide them by 2. Put a great big bracket around here. This is a big coordinate point. Now start by just writing them like this, and then see if you can tidy up each algebraic expression to get it looking nice. Now if I average the y's, I've got 2c and 0. Write them in. 2c plus 0. Obviously adding 0 is nothing, but I'm showing all my working here, so I'm really sure of what I'm doing. And I'm going to have to tidy this one up, so I may as well write that down, have a look at it and think about it. Now I can tidy up. Now everything here is divisible by 2. So this is just really a plus b, isn't it? So a plus b is the x value, and 2c plus nothing is just 2c. And if I divide it by 2, I just have c. So that would be point P. Now to find point Q, same sort of thing. Let's go down here. Now I'm not going to write out this formula again, I'm just going to go ahead and use it. We need to just average, and down here I'm going to write in what the x and y values are. 2b plus 0 divided by 2. And the other one's going to be 2c plus 0 divided by 2. Tidying up, I've got b, because 2b divided by 2 is just b, and c. So that's a nice simple one. So once you've found something, go ahead and put it back onto your picture so that you can visualise it and use it for the next step. So Q is the point BC. There we go. All right, for the next part, we need to show that PQ is parallel to AC. Now, have a look at the points that we found, and let's see what we know. To prove they're parallel, we could find their gradients, couldn't we, and see if they're the same. But having a look at this, I've noticed something. We've got PQ, that's this line. Let's draw the line in so we can think about it. Now, the y value here is c, and the y value of this one is also c, which means both of these are lining up with the c, aren't they? So this is a horizontal line, and how can I tell? Well, y equals c for both of them, And that is the very definition of a horizontal line, y equals c, that goes right through. So I can write here for part B, I'm going to write PQ is horizontal. Now, if you write something down, write in brackets how you know it. Let's say both P and Q have y coordinates C. Okay, now what about the other line, AC? Well, they're both on the x-axis, aren't they? So we'd write AC is also horizontal, A and C on x-axis. Therefore, PQ is parallel to AC. So you state what you know, and then you use that to answer, and you've shown that that's the case. Now it says we also need to show that PQ is equal to half AC. Now, they haven't said here what to do. PQ is a distance, isn't it? And AC is a distance. So we're going to need to give ourselves a bit of space here for this next part. You just work on down in your book. Now, what is the length of PQ? Well, we know the distance formula. Let's go ahead and apply it for both. PQ is equal to, we need the square root of. Now, we need to do, you can go ahead and write the formula if you like. We need to subtract one x from the other and square it, and then we need to subtract one y from the other and square it. You might like to put 2 minus 1, 2 minus 1, or 1 minus 2, it really doesn't matter. So in this case, we need to take the x values. We've got a plus b. Let's do this one, minus b, because I can see that's going to be nice and easy. We've got a plus b minus b, all squared. And the to take c minus c, well, that's going to give us nothing, isn't it? But see how this is a show that question? If I get something like c minus c, I know in my head that that's 0. I still write it down at this point because I'm showing, I'm proving that I'm going to get the answer that I'm going to get. Okay, so on the next step, I know b minus b is nothing. So in here I've just got square root of a squared, and I'm adding c minus c, that's nothing. Nothing squared is nothing. So I end up with this. Now what's the square root of a squared? Well, you've taken a, squared it, and found the square root of it. It's just a, isn't it? So PQ equals A. All right, now we've got to find AC. We'll see what it is. Okay, AC equals, now I'm not going to write out the full version of the formula again. Let's just go straight to subbing in what we know. So AC, we need to do one x value minus the other. Let's do 2a minus nothing. And square it. And then add it to the y values, subtracted from each other, 0 minus 0. Again, it's a show that question, so I'm going to really spell it out so it's obvious. Now I know that 0 minus 0 is 0, and you square that, it's still 0. And over here, this is just 2a squared. Now, if I've got 2a, and I've squared it, but I've also taken the square root of it, those two operations undo each other, don't they? So I've really just got 2a. Now, we're asked to prove that PQ is the same as half of AC. Well, if AC equals 2A, what's half of AC? Let's write it down and really spell it out. Half of AC is just half of that, which is equal to PQ. Now, when you feel like you've done what they've asked you to do, it's kind of handy to write at the end, as required. So we were required to show it, and we've proven it, and it's logical and it flows. One nice thing to do is maybe put a box around the important things that you arrived on the way so that an examiner can really see how your thinking flowed and how you showed your answer by the end.